Okay, so we're looking at page 68 on the textbook. So, ratios. We're talking about a ratio. And we've done work on fractions, you know how to do stuff with fractions. So we're talking about ratios and how we can use ratios. But ratios are very similar to fractions and we can do a lot of the same stuff. But there is a slight difference. Okay? But we're still expressing amounts. We're comparing different amounts. Okay? But before we talk ratio, let's just say, let's imagine I have a cake and this cake is split into this many pieces, however many it's going to end up with. Right, so how many pieces have I got of cake? 6, okay? And let's say I take that piece and that piece. What fraction of the cake do I get? 2/6. What fraction of the cake do you get if you get the rest? 4/6. Okay? Because if I add those together, I get 6/6, which is the whole cake. Now, I can express that in a different way, though. Okay? Pardon? It's not 2 common 6, but I get it works. So what we do, so what a fraction does, a fraction tells me how much I get with the total amount. Okay? So exactly. So a ratio does it slightly differently. And a ratio would be 2 to 4. Okay? So using a fraction, I can tell what I get, I can tell what the total is, I can work out how much you get. But a ratio is what I get and what you get. So I compare directly what you get and I get directly like that. So I can still tell how many there is in total, can't I? Because I know that 2 plus 4 makes the 6. Alright. Now the thing is, with ratio, the same with fractions, we're comparing like amounts. So you can't do fractions with different denominators. So when you add them up, you have to have the same denominator. And it's the same with ratio, so we talk about comparing the same amounts. Now, just looking at those fractions though, of course, one of you wanted to jump in and say, but you could simplify that, couldn't you? So the fractions would simplify to 1/3, yeah? And so I would actually get 1, imagine I get 1 for every 3, yeah? So I get 1 for those 3 and I get 1 for those 3. So I get 1 out of 3, and you would get 2 out of 3. Okay? But if I considered it like that, I would now get 3 out of 3, which equals 1, the same thing. Now, how could I express that one as a ratio? Okay. 1 to 2. Yeah? 1 to 2. Well, how we say it is, it's 1 to 2. Or another way of saying it would be 1 for every 2. Okay? So what that means is they are equivalent statements. So 2 to 4 is equivalent to 1 to 2. Okay? Just like 2/6 is equivalent to 1/3. So we can simplify in the same way. Right? And it makes sense because if for every 2 I get, you have to have 4. then when I've got 1, you're going to end up with 2, aren't you? So if I get half as much, you're going to end up with half as much. And we're comparing things like that. Alright? And we can simplify or do equivalent. So just like you were doing before in that starter, where you said 5 to 8 is 10 to 16 is 20 to 32. So imagine if I said to you, for every $5 I get, you get $8. Well, if I get $30, you're going to have $48. Yeah? So for every 5 I've got, you've got to have 48. Alright? Now, as a fraction, right, if I get $30, so let's just have a write this one down. So the question is, if I get, so what did we say? So we had the ratio 5 to 8, we had that in that starter. And basically, if I give it a context that says, for every $5 I get, you have to have $8. Well, if I then get $30, you have to have $48. Now, what fraction, Nick, would you be guessing? If I get $30 and you get 48, what fraction would you be getting? You're getting the 48. So what fraction would you be getting? So that, remember the difference. So that's the ratio. I get 30, you get 48. That's where we compare to each other. See that? So I would get 30 over 78, and you would get 48 out of 78. You see the difference? Yeah? So that's how we can compare. So that's the relationship between fractions and ratio. Right? And not a lot of people get that. I think they're a bit different. So let's have a quick look then. So you should be able to do an awful lot of this stuff in the book now. First of all, so exercise 3G.1. Come on, you do that. 3G.1. So let's just have a look. Express as a ratio. So, have you done map work before in geography? Looked at scales in maps and things? No, you've not done that. So we'll probably talk about that a bit as well. Right. So, in question 1, it says express as a ratio 6 millilitres to 11 millilitres. 6 to 11. Okay? Do you know what that context might be? What might we be looking at if we're talking of a ratio 6 millilitres to 11 millilitres? Drink in what way? There's small amounts, so it's a bit different. But yeah, when do you mix drink? Yeah, I'm telling you, mix fluids in science, definitely. Yeah, science, maybe you've got to mix acid and alkaline in different quantities, different proportions. So maybe you have to do 6 millilitres to 11 millilitres. So for every 6 of one, you put 11 of another. Have you mixed cordial syrup in water to make yourself a drink? So 6 to 11 would make probably quite a strong one, but you know, that's what we do. So question 1, nice and easy. Just having a look, so you can carry on, but question 4, so 90, it says 93 centimetres to 1 metre. Nice.
We have to change it, that's what we learned actually.
Say the right.
Usually, wait, unusual.
Yeah, usually drink.
Why? How does that happen? I've never heard that.
Because it's,
So you would be like,
it's.
I don't think you said it right.
Pardon?
they write it on the board.
Oh, yeah, right in the board. Right?
No, it's just drinking John.
Yeah, that's not. So like that.
No, there isn't you.
Yeah,
No,
there
there's
is a
you.
U.
There's you for N's. It's
No,
units,
parents.
that's
And then this would be the units one. So
Yeah.
like if you have to
That's
convert it.
Oh, okay, right, yeah, yeah. So,
Oh,
That's right.
yeah.
yeah. So, you know, though, the problem with this one, so you're already saying, that the units matter, don't they? So this one was millilitres and millilitres, so we're absolutely fine. You'll notice that the ratio doesn't have units. Ratio does not have units. So I could write this ratio in a couple of ways. What would I write it as? Okay, so it would be 93 to what? 100. Yeah? Or 1 to not 9.3. Yeah, 0.93. So this is where ratios can have decimals. This, by the way, this one here, oh, sorry about my light. This one would be considered in the form of n to 1. It's what we call a unit ratio, where one of the ratios is 1. Okay? So like with fractions, unit fractions, where you simplify down to 1 over. So I tell you what, I'll let you get on. You can carry on, do all of that exercise 3G.1, carry on to 3G.2 if you wish, if it makes sense and it's reminding you now. Okay. Ask for any help you need. So, simplest form. Now you already know about simplest form of a fraction. So if I said 21 over 24, right, is that in simplest form? Why? Okay, so if I divide by 3, top and bottom, I get 7/8. But that's simplest form, yeah? Okay. We have the same process in ratio. So if I've got 21, okay, to, what would it be actually? No, actually what would the ratio be? 21 to 3, okay? So that ratio would represent this, the fraction that I'm talking about. So what would simplest form be of the ratio? Divide by 3 again. 1 to 7. Or 7 to 1, we have to read left to right. And it does matter which way round it goes. So, for instance, question 2, it says, what's the ratio of pens to pencils? So pens to pencils is 4 to 3. Pencils to pens would be 3 to 4, so we have to get it right. Now, that is, so let me just talk through maybe the harder ones they talked about. So you've done the process, you've done it with fractions, so you can do it with ratios. But ratios can be expressed like this. Okay? Because ratios can have decimals. They can. Yeah, they can have fractions in them, they can have decimals. Fractions can't, but ratios can. Alright? So, simplest form of a ratio is still the lowest whole numbers we can have. Alright? So what would it be in this case? So this is not simplest form. Well, what would happen if I divide by 3 with 5 to 2, 5 over 2 to,
I don't know. Divide by 2.
not divide by 2, but if I multiply both by 2, what do I get?
Oh, 10.
Don't.
Sorry.
Nope.
Oh,
10 over.
Nope. Because it's 5 over 2 is 5 divided by 2. So if I do 5 divided by 2 times 2, what do I get? Did you get that, Hog? Packen?
Okay.
Did you get that? You hear what she said? No, listen then. Okay? She said, if I do 5 over 2 times 2, I get 5. And 3 over 2 times 2 is 3. Now that is lowest or simplest form. Okay? So simplest form. Now, I could make it harder by doing, what if I had 5 over 2, 5 halves, 2, 3 quarters. Well, I'm not going to divide because I've already got division, because a fraction is a division. Well, don't forget, like with fractions, you have to multiply both things by the same amount.
Times by 4.
So if I times both by 4, okay, what do I get? Well, this side, I get, the right-hand side, what do I get?
4.
No.
I didn't have 1 to 5.
No, I'm talking about the right-hand side, sorry. So if
Yeah,
I, 3, good, yeah. So this side would be 3, this is running out of battery, that's why. Right, so the right-hand side would be 3. What would the left-hand side be? It wouldn't.
5.
Oh, sorry, no, it would be 10, wouldn't it? Why would it be 10? Yeah. So I've multiplied, now this one I haven't multiplied by the 2, I had to multiply by 4 to get this one sorted. Okay? So this would be simplest form. So when you get those fractions in the later question, that's what it will be. Okay? I'll let you carry on.